Today, I will give a class to talk about of course, depending on different applications and different models, generative AI generative AI models have different architectures. So that's why this class will be a little bit complicated, because depending on applications, we're gonna talk about many different types of AI architectures. But anyway, most common part of that training process is that we are giving them input data and we are observing output. And if the output is not correct or precise, we are updating the weight matrices. That is being called as a backpropagation. But when we are exciting the backpropagations, we have to measure difference between output and real data. And that description is represented by a loss function. Sometimes we are saying it as a cost function. In the cost function or loss function, we are giving the generative AI a homework. What's right or what's wrong? What is our target or what is our goal? That will be included in the description of cost function. So with that perspective, I think cost function and loss function is most important and core part of generative AI algorithm. There are three types of cost function, 3 or 4. One of them is mean square error function. Second type of cost function is entropy function. And the third one is KL divergence. And I reviewed many different types of generative AI models, and I found that most of them are using those loss functions. So this class, in that regard, this class will be a very important part of the whole semester class. Let's assume we have generative AI, and it will be represented by a set of weight matrices. The number of elements in this weight matrix could be 1 billion or 100 billion in the future. The purpose of training process of generative AI is actually to optimize this weight matrix to give you, to make it optimal of value. Then usually, if you have reached it to an optimal point of weight matrices, then we have minimal value of loss function. Input vector is represented by X vector, and its element is starting from X1 to X2 to Xm. Actually, M is a very large value number, but in the class, we're gonna assume like a 2 or 3 to simplify the class contents. And then output of this generative AI can be expressed by a Y vector, Y1, Y2, and Yn. This is input to the generative AI. This is output of generative AI. In most cases, during the training process of generative AI, you need a reference. This Y dash could be obtained from real data or sometimes self data during the training process. Sometimes during the training process of generative AI, we are trying to repeat input to the output. And this Y dash matrix may be symbolized as self data. In this structure, this X could be text or image, sound, or music. Input data could have many different types of format. This text data can be obtained from the world of SNS or from a book in library or your report. Image can be obtained from your smartphone SNS. You are uploading many pictures into the website. Sometimes YouTube material can be used as an input vector. Then this output is also have a form of text, image, sound, music. Eventually, in the long future, I think generative AI can generate a movie. Movie has all the elements of text, image, sound, and music. This kind of generative AI model is called as a multi-mode generative AI. In order to realize multi-mode generative AI, we need huge amount of computing power. Computing power is recently enabled by GPU and HBM memory. Assuming that we are still using the von Neumann computer architecture. Plus, we may need huge amount of data to train this generative AI model. That means we have to optimize weight matrix of the generative AI. You remember that when you input this data, we're gonna obtain the output. This process is called as forward propagation. If there is some difference between your output data and real data, you have to update this weight matrix. That process is being called as back propagation. there are various different types of generative AI architectures, but these frameworks are always the same. In order to achieve this multimodal generative AI, there are some different types of AI. In my class in this semester, we're gonna discuss about RNN, LSTM, and transformer learning, and GAN, and VAE, and diffusion. So in this class, for last couple of months, I'm going to introduce the architecture of RNN, LSTM, and transformer model, as well as GAN, VAE, and diffusion model. Each model are specifically useful for an architecture. For example, if you input the text, we're gonna obtain the output text, like English translation. And sometimes in generative AI models, such as diffusion model, we're gonna input text and output will be a kind of image. So for the next couple of months, I'm going to give you details about this generative architecture. But there are so when we start back propagation, we have to define a loss function. Loss function is a description of difference between real data, your target data, and your output. If the difference is large, they're gonna accelerate back propagation with larger amount. This loss function will be determined based on your goal. What is your goal? Depending on your goal, you may have different loss function. And also you may have different value. Depending on your value of your generative AI, we're gonna define different loss function. And efficiency. How fast we're gonna complete this iteration of forward propagation and backward propagation. If you decide some loss function, but if it takes longer time to optimize the weight matrix, then it takes more computing power. It will delay your training time. But humans are not patient enough to wait. They wanna have instant response or instant training. For example, I'm assuming that we have some world news an hour ago. I hope that is updated to your generative AI, so that if you are writing a report, that immediate global news should be included in that. So instant training and instant response is very crucial element of generative AI requirement. So efficiency means time and power consumption. Eventually, depending on the choice of loss function, your generative AI may have different time and power and cost. Also, loss function is depending on the architecture. In this class, I'm going to introduce 4 different types of loss function that are commonly used in generative AI. Number 1 is mean square error function. it is easy to understand the meaning of this mean square error function, but in general case of generative AI, this MSE are rarely being used. So, but for the perspective of education, square of difference of real data and your output, because we have n element from y1 to yn in this output vector, we have to make a summation. In some text, these generative AI parameters are represented by W, that is my preference. In some text, they are using theta. In mathematicians usually use theta, and engineer myself are usually using the weight matrix W. We have to optimize we have by applying the iteration of forward process, propagation and backward process, we're gonna update these parameters to reach up to a point where this whole summation is becoming a minimal point. Of course, simply speaking, and mathematically it is very simple. If yk and yk dash is equal to each other, same, this value will become minimal point. Second type of loss function is entropy. Later in this class, I'm going to go deeply into the meaning of entropy. Entropy is amount of information contained in y1, y2, and yn. If we have output yn, we can calculate all the information included in y1, y2, and yn. Mathematical description of information is learned from information theory, from your communication class or some other classes. So one way to define entropy is later on, I will go more deeply into that, this meaning of this equation. Log 2 yi means amount of 2-bit distal bits, number of bits to describe yi. And I'm assuming that yi value is between 0 to 1. This yi is actually the probability. In order to be a probability, all the summation of y1 to yn should be equal to 1, total amount of that. And that function is being called a softmax function. Probably next class, in the next class, I'm going to give you more understanding of softmax. But at this moment, we are assuming that y1, y2, and yn is the probability distribution. For example, if you give an image of tiger probability distribution is whether it is tiger, cat, dog, or lions, or something like that. So this will be a probability distribution. And then log 2 yi minus means the amount of information to represent all this output. So one of the cost function we can use for generative AI is we have to minimize the entropy of output of your deep neural network. One day I was thinking, why is that? Later, mathematically, I will explain that. If output of y vector has some value which is close to 1, and if the other is becoming 0, that is the best case of entropy. So we can give the loss function as an entropy. That means we want to distinguish outputs. If we have a big separation of probability distribution, the generative AI like that. If we have uniform distribution of output, we usually generative AI doesn't like that. They want to have clear identification or very clear discriminations. Mathematically, that is being called as entropy. One of the entropy, this is the total amount of information represented by bit 2. Why we are using log 2? Because in these days, every information of input and output data is represented by a digital data, 1 or 0. So that's why we are having 2. The basic difference is 2. Because our DRAM has 2-bit information, whether 0 or 1. Our GPU, digital computer, also only deals with binary data. So if we have large number of entropy, that means we need a huge computer or huge memory. That means efficiency is going to be extremely low. And by using this entropy function, we put more value on separation rather than uniform distribution. I don't know that is good for human being. We want to, if I have a good food, I usually want to share with TA and with the students. But generative AI doesn't like that. He's has opposite character. They want to distinguish. They want to put all the money to the one student and kick away all the other students. I'm not that kind of person. I like average, and I want to make you are my sons and daughters. Every finger has pain. So I'm not good in generative AI. I'm a human AI. That's the difference. And that mathematically that is represented by this entropy function. So a third one is, I would say, cross entropy. Sometimes this is being used. This information, 2-bit information of output is multiplied by real data probability. Here, cross entropy means that we go one step further of discrimination philosophy in generative AI. Here, by applying the entropy, we already like discrimination. We want to focus on one data. By multiplying y1 dash, which is also probability distribution, we only consider more attention who has large y dash. Let's assume you have 0, 0, 1, 0, 0. Who has 1? That is our concern. So y1 dash is the real probability multiplied by the information of output yi. This means average or this is more likely meaningful information represented by log 2. First entropy is a kind of average information to train the generative AI. But here, number 3 is we do not have enough computing power or attention. We only focused on certain entropy. Certain entropy is selected where y dash, real data, has higher probability. If your input picture is like a tigers, when you are calculating the output entropy, you only consider who has the tiger. Wrong answer is not considered significantly. So this one is more likely we are adding attention. Attention is obtained by real data distribution. You know, my background is very high frequency electromagnetics and semiconductor. Especially recently, I'm focusing on my research on 3-dimensional packaging design for GPU and HBM. This is more likely mathematics and statistics, and I have a little bit difficult to explain that, but I watch many textbooks, but there are not much more explanations on this. I'm comfortable with this. The first loss function that are commonly used in generative AI is KL divergence. That means in particular, please remember that in the diffusion model, you remember DALL-E 2 from OpenAI and Stable Diffusion, that is very popular generative AI in these days, and transform model. Most of them are using KL divergence loss function. The first term is actually cross entropy between y dash and y, and this is actually self entropy P of y dash. KL divergence actually means the difference between real entropy and our output entropy. In the mean square error function, we directly use the difference of value of your generative AI output and difference, just numerical difference. But later on, I will give you that this square function derivative, it is not large number. So training process is not efficient. But if you have entropy function, it's kind of log function, derivative that has very huge number, near 0, probability 0 or probability 1. So it usually has very fast training process. And how are we gonna define the difference between your output and reference data? Here, you are just using parabolic difference between these two. But in KL divergence, we are comparing cross entropy and self entropy. Self entropy is purely obtained by y dash. Y dash is the real, so entropy of output, entropy of cross entropy between output and real data, we compare them. And by applying this KL divergence as your loss function, you obtain the derivative, and you are using this derivative of your loss function with respect to weight matrix. You can obtain the gradient. And then in the previous classes, I was showing the chain rule equations. W2, W1, W0, sequentially we can obtain that. But there are some problems associated with this approach. One of them is we have to have very good gradient so that we can effectively reach to an optimal point. And yeah, I forgot what I want to say, but this is the overall picture of our class today. I'd like to summarize at this moment again. In the generative AI, during the training process, we have to execute forward propagation and backward propagation. Backward propagation is represented by gradient descent method. And in the previous classes, I was showing that we can do that by deriving the chain rules. In the next sequential classes, I'm gonna give you this back propagation and chain rule equations for many different type generative AI. But when we start back propagation, we have to define what is right and what is wrong. What is right and wrong is your value system, or that will define your goal of generative AI. And of course, when we start the back propagation, we have to represent mathematical formula to apply your philosophy and value system. That is being called as loss function. And if you define loss function, you have to be able to derive the gradient, derivative of them, and then we can start the back propagation. And commonly, I don't know, in the future, there might be many different types of loss function, and probably. And so far, I can say that there are 4 different types of loss function. Number 1 is mean square error. Second is entropy. Third one is cross entropy. Last one is KL divergence. But based on my experience, many of the currently commonly used generative AI are using this KL divergence. KL divergence means the difference between entropy of real data and entropy of your output. If your both entropy are very close to each other, you're gonna complete your iteration and you're gonna complete the back propagation. Why we choose entropy rather than just simple difference? That it is associated with value and efficiency. But my philosophy is that in these days, AI, generative AI is computed, are asking a lot of huge computational power in GPU cores and parallel computing and supercomputer. And also we need the high bandwidth memory HBM. So it takes huge amount of energy and resources. So when we are determining this weight matrix of generative AI, we want to maximize the efficiency. That is against human being. In every day, when I have 2 phases. One phase, I love people, family, students, and something like that. Another part of my phase is that I pursue efficiency. I want to make a schedule so that I have to survive and I have to make a maximum productivity of research and classes. So sometimes my friends is calling me to have a dinner together, or my wife is asking, let's go to South Asia during the Chuseok holidays and Jeju Island. And I have money, but I don't have time. I say, this is the last year. I want to really study hard. Please give me free time. I want to, for example, yesterday on Sunday, my wife is staying in the living room and watching TV. And I talked to my wife, don't touch me or don't tell any word in a whole day. But my wife is so nice that, okay. I said, tomorrow I have a class, I have to prepare that. She has high value on students and class. So I have two faces, humanity and efficiency. But in terms of efficiency, I think this entropy is an algorithm. I think this algorithm doesn't look like a human being, but very efficiency-wise. In terms of 2-bit efficiency, this is the introduction of loss function of generative AI. I'm gonna go a little bit step further and further to talk about these 4 different type of loss function. I was planning to complete today's class to talk about more of this one, but it seems like I already have more than 30 minutes. So in the next class, I'm gonna go again and again. So let's start with entropy. I said this KL divergence entropy loss function is more targeting for efficiency, higher efficiency, and fast training process. I told you that I have 2 phases, human phase and generative AI phase. If I want to do more research on generative AI and I want to encourage my students more and more, sometimes I have resources. I need resources. If I want to give you more stipend to the student, that is human part, but I need the money. In order to do that, I have to bring the big project from government or industry. So in the future, you need to have balance between human nature of your character and AI nature of character. So don't put your life into the entropy. That is maybe 30 or 40% of your life and time. Probably 70, 60%, you are pursuing higher entropy. Sometimes in the daytime, you are pursuing low entropy to maximize the efficiency, but sometimes please pursue higher entropy, whereas the so go back and forth. Every hour, that is not good. Maybe daytime, you focused on the efficiency, and after work, you have to pursue human life. That is called balance between work and life. This entropy is extremely efficiency target. So now I'd like to talk about entropy. Let's assume you have coin. You threw the coin, and sometimes if you throw the coin on the floor, sometimes it will stand as face up or face down. So probability is face up. Then you need only 1 bit information is enough. Face up can be represented by 0, face down can be represented by 1. So let's assume that you have generative AI and it will predict whether your coin will face up or face down. Anyway, information needed for coin face up or face down, we only need 1 bit digital information. So information about this one is just 1 bit. However, if you are throwing a cube, probability of 1, 2, 3, 4, 5, 6 will be 1/6, 1/6, 1/6. So status to express the information about the state of this cube is just we need 3 bit. 11001 or 002 010. And anyway, all the 6 status of your cube can be represented by 3 bit digital information. If your computer want to store status of your coin, you need just 1 bit memory. If your computer has to store information about your cubic status, you need 3 bit. So this entropy of this one entropy of cube. So in some of the generative AI are using this entropy as a loss function. That means they want to have low bit information. Let's assume your yi is equal to let's assume you have another type of yi. It has this first one is uniform distribution. Let's assume you have a uniform distribution of your generative AI output. And second case is where you have only single one as a certain index number j. If you choose entropy as a loss function, this entropy is much lower number. By having forward propagation and backward propagation, we want to achieve this second probability distribution, who has distinctive output probability distribution. Uniform data distribution like cubic, entropy is large number. And sometimes in generative AI, in most cases, we prefer to have lower entropy. If we have only a single index has a probability 1, all the others are 0, then we only need 1 bit to describe that. But if we have a uniform distributions, we cannot distinguish which is right or which is wrong. Generative AI doesn't like that situation. In the graphical representation, in the entropy formula, we have minus log 2 yi. Y is actually probability distribution of output. If yi is becoming near to 1, that is this case, near to 1, because of this is log function, this entropy function is becoming 0. That is the minimal point. And during the backpropagation, we want to find the optimal weight which give you the minimal loss function. And by representing this information to describe your output distribution of generative AI, by having log 2 yi function and we have minus, you understand this is a log 2p function. In the high school or engineering mathematics, you know that this is log function. By having minus sign here, it has decaying function. So if you have probability 1, that is this case, you're gonna have minimal entropy. But if you have 0, somehow this kind of distribution, very small number near the 0, then this entropy, if p is becoming really small number, this becoming maximal number. And the slope is really fast. That is the beauty of this entropy function. So it will start the gradient descent very fast near 0. Somehow it is slow near probability is 1. Now, so far, I was talking about the basic meaning of entropy. Now, I will go a little bit further into cross entropy. In the previous loss function, I was talking about the meaning of entropy. Just minimize the entropy, minimize the necessary amount of information by 2 bits. But next one is cross entropy. We are multiplying the real data probability distribution. So cross entropy is a little bit more useful because we don't need to care about all the entropy of output. Only we care about important entropy of output. Who is determining the importance of the yi? You remember that we have y1, y2, and yn, and this is output of generative AI. We have y1 dash, y2 dash, or yn dash. This could be generative AI output of drawing new picture. This could be a drawing of Picasso. You want to train this generative AI so that he can draw a new picture or images very close to Picasso style. But anyway, in the cross entropy case, you are only considering you are not taking care of any of the real data. You just focused on yourself and minimize the information bit amount to describe this one. But cross entropy is obtained by multiplying who has higher probability at real data. We account more on that. For example, let's assume that your y dash is 0, 0, 1, 0, 0, 0, 0. Only third bit is your concern. Then in this cross entropy, you only calculate entropy of third bit. So distribution of your reference data or real data is put onto this loss function as a term of multiplication. This is actually probability. This is entropy. And this is real data probability, probability distribution function. Now let's talk about the last one, KL divergence. It's a little bit complicated to explain the meaning and concept of KL divergence, but it's the difference between cross entropy and self entropy. The second term, self entropy, means actually this one means this is the entropy of real data, reference data, Picasso picture. Picasso picture, let's assume you have some certain picture and it may have certain distributions. Distribution could be a color or intensity or whatever. If you have an input vector x and y dash, let's assume it is a myself picture. Generative AI can draw a picture of myself and it may have certain distributions. This could be color or black and white or light intensity or contrast. We can define many different ways. We may have certain distributions. If we are using entropy, we just want to minimize the information contained in this picture. That is the goal of training of generative AI. Second case is cross entropy. And we calculate amount of entropy information that is relevant to real data. We want the last entropy function, the loss function that is called as KL divergence. That is the comparison between cross entropy between y and y dash and real data entropy. So if both entropy are very similar to each other, then we assuming it is a good generative AI training. This will be the end of class today. I'm in the next class. Here in this class today, I was assuming more, I'm using more mathematics to describe the meaning of loss function, but in the next class, I'm gonna give you more real cases so that you can easily figure out. Thank you for your attention. And in this class, we're gonna explain the architecture of RNN, LSTM, and the transform model and diffusion model. All of them are mostly using these 4 different types of loss function. So we're gonna revisit again and again. Also, we will be able to have a chance to derive all the gradient dismultiplication and chambers. I think this is most essential part of the generative AI in terms of mathematics and concept. So I want to spend a little bit more time to discuss about that. And another part of generative AI is what is the architecture? Serial, parallel, feedback, and that combinations, I'm gonna talk about that. Thank you for your attention.